Factoring Notes Part 2. So, we're continuing looking at factoring, which is unmultiplying, breaking things that are already multiplied up into what multiplied together to equal them. This is that same idea of when we had 6, we made it into 2 times 3. What two things multiply together to be 6? 2 times 3 is its prime factorization. There's other things that multiply together to be 6. 1 times 6 equals 6. But those aren't the prime factors, the smaller parts that do it. 1 times anything is itself. Whoa. So we looked at the distributive property. We have something outside parentheses times 2 things added together inside parentheses equals that outside part times the first thing added together, and the outside part times the second thing added together. So the product of two binomials, a plus b times c plus d, a plus b being one binomial, c plus d being another binomial, multiplied together here, equals ac plus ad plus bc plus bd. Why? Well, we have 2 things added together in parentheses, just like we have 2 things added together in parentheses in our distributive property. And we still have something in front of it. This time the something is the entire set of parentheses. So our a in the distributive property, when we're looking at a product of 2 binomials, is the entire set of parentheses a plus b. So that when we distribute this set of parentheses into or over the first addition, you would have a plus b times c plus a plus b times d. Now you can rearrange those. Multiplication being commutative means you can switch it around so that it looks the way you want it to look. Oh, but now we have something in front times things added together into the parentheses, so that we can use the distributive property again to get a times d plus b times d plus a times d plus b times d. And then addition being commutative means we can switch the order of these two to AC plus AD plus BC plus BD. All properties of multiplication and addition going on here. So that's where this product of 2 binomials comes from. It's not a magical formula. It's just using the property we already know twice. This is important because I'm going to explain factoring trinomials in the same pattern, using the distributive property twice from the right-hand side to the left-hand side, coming back this way 2 times, once from here to here, and another time from here to there. So that's why I explain this part like this. Lots of people know this shortcut as FOIL. First, outside, inside, last. Multiply the first term in each parenthesis together. The first term is A in the first set of parentheses. The first term is C in the second set of parentheses, so A times C. Then look at it from what are the outside terms and the inside terms of the 2 things multiplied together. So outside is A times D. Inside is B times C. So outside, inside, and then the last term in each set of parentheses. The last terms are B and D, so multiplying those 2 together. When you add all that together, that's what we're talking about. AC plus AD plus BC plus BD. First, outside, inside, last. One of the more popular ways to remember the multiplication of 2 binomials, called the FOIL method. Notice that this is exactly what we just did. It's just a trick, a shortcut for remembering how to do it with no work. How do we get this out of AB plus CD, or A plus B times C plus D? FOIL is a great way to remember it if we don't want to remember our double distribution that it actually comes from. There's lots of this in math. The actual mathematical background for something versus the shortcut, the trick that almost everybody uses to do it anyways. So, factoring trinomials is what we're going to be looking at here. We're taking x squared plus 3x plus 2 and factoring it into the two sets of parentheses that are going to multiply together to be it. So x plus 2 times x plus 1 will multiply together to be x squared plus 3x plus 2. First, x times x. Outside, x times 1. Inside, 2 times x. And last, 2 times 1. When you combine your like terms, the 1x and 2x in the middle, get you x squared plus 3x plus 2. So yes, indeed, these two things are the two factors, the things that multiply together to be x squared plus 3x plus 2. So how can we start with something like x squared plus 3x plus 2, a trinomial, and work our way backwards to get this step, x squared plus 1x plus 2x plus 2, so that we can factor out the common factors of the two parts using the distributive property, and then use the distributive property again to actually get our answer. That's our question, because not everything is going to be easy to see and factor in our heads. I'm going to give you a lot of problems over this year that aren't going to be your Algebra 1, oh, I can just do this in my head problems. And so that's where the methodology I'm going to teach you comes in. That's what this process is for. The process I'm going to teach you is very specific to factoring trinomials that are hard. It works all the time. Not, well, when I'm awake and doing well and had a good breakfast and no one's been mean to me that day, then I can factor. What good does that do you? None. You want to be able to factor all the time. No matter how terrible a night you had, no matter that your parents took away your cell phone and didn't let you go to the movies with your best friend, none of that stuff matters when it comes down to test time and you have to be able to factor. That's what this method does. It takes all trickery out of it. There's no magic involved. It's, can you follow the steps? Do you know what's going on? That's why I like it. That's one of the reasons I like it. Seems like a lot of steps, but a lot of this is scratch work and stuff that we do in our head anyways. So, the first step, going back to our notes part 1, we always want to look for a common factor. It's got to be our first step. And you always want them in descending order, which means highest power to lowest power. X squared, then x, then the constant. And then you're going to multiply your first and last terms together. So we have 3 terms, a first term, a middle term, and a last term. X squared being the first term, negative 48 being the last term. We're looking for what multiplies together to be what we just got, the first and last terms multiplied together, but adds together to be this middle term. So what multiplies together to be negative 48 and adds together to be negative 13. So that's the trick here. What multiplies together to be what you get in step 2, but adds together to be the middle term of your trinomial. So that's what 3, 4 do for you. Steps 3 and 4 find you what multiplies together to be the negative 48 in this case, and adds together to be our middle term, negative 13. List all the factors for the expression we just got. So this list seems tedious to a lot of people, but works on our number sense quite significantly. It's a great thing to be doing, making a pair of numbers multiplied together list. Negative 1 times 48. You're just going to go in order. Negative 2 times 24. Negative 3 times 16. Negative 4 times 12. Negative 5 doesn't multiply by an even number to get 48. It multiplies by a fraction or a decimal. And so we don't care about 5. But what about 6? Negative 6 times 8 is 48. And then we switch. Negative 7 times nothing again. Nothing gives you an even multiple to get to 48. Negative 8 times 6. And now we already know stuff because we're at 8 times 6, which is just the reverse of the previous one, 6 times 8. And so the rest of the list fills itself in quite easily because you're just switching the number pairs around. And you're looking now for what multiplies together to be negative 48 and adds together to be negative 13. We don't often write out the full list. Usually we just write out half the list, knowing that the other half is those same numbers, just the signs are reversed. And so when I got to negative 3 and 16, in my head I was adding those together, and I got negative 3 plus 16 is positive 13, which means if I switch the signs to negative 6 and 13, when I add those two together, negative 6 plus 13 is negative 13. So I found the two numbers that multiply together to be the first times the last and add together to be the middle. So now I can do the actual factoring. All of what we've done is scratch work, is work that goes off to the side. Your actual problem, you copy down the original problem. Then you go to step 5. You rewrite your middle term, having done our scratch work off to the side. We're going to say this is negative 16x plus 3x instead of negative 13x. Notice here that the negative 16x plus the 3x is indeed the negative 13x. These are equivalent expressions. All we did was rewrite the negative 13x into two terms. But now we have 4 terms like we had 4 terms when we were doing our distribution. So now we're going to undistribute. So that's what the next few steps are telling us to do. Look at the first 2 terms. What do they have in common? X squared minus 16x. Factor out the common factor, the common x, leaving us with an x minus 16. That's step 6. Step 7, factor out the common factor of the last 2 terms. So there's our last 2 terms now. Plus 3x minus 48 has a 3 in common. So we're going to factor out that common 3. But that leaves us with 2 binomials that are the same, x minus 16 and x minus 16, multiplied by an x and a plus 3. And so we're now going to factor out that common x minus 16, leaving us with what they don't have in common, x plus 3, in our parentheses. So that's the double use of the distribution property backwards there. Here's using it once, here's using it twice. The distribution property backwards. What's inside our parentheses has to match in order for this to work. If those two things aren't the same, then we can't factor out the common factor because they won't be common. they'll be different. And so we got to look for that part. We got to make sure that the two factors in the parentheses match and can factor out. That's a step in and of itself in my list of steps. The two factors in parentheses must match and can factor out. If they don't match, then we probably did something wrong, and we just got to go find out what we did wrong. But if you don't check, if you just start randomly doing things, that's where you get into trouble. So, know that there's a step in here that's just looking at it and saying, do those two things match? Sweet. If they do, factor them out. If they don't, bad stuff, bad Joju. Go do something else. All right, we have 5 examples to do. So if you need to take a break, pause it, take a break. We're going to run through 5 examples of this, 2 regular factorings, and then 3 using the zero product property, and you'll get to see some factoring that way. Okay, so example A. Trinomial, x squared minus 29x plus 100. The 3 terms don't have anything in common. So off to the side, doing our scratch work, we multiply the first and last together, we get 100x squared. That's 1 times 100, 2 times 50, 4 times 25. We know we can switch all the signs, so 4 plus 25 is 29, but we want negative 4 and negative 25, because a negative times a negative is still positive 100. But when we add them together, negative 4 plus negative 25 is indeed negative 29. We split our middle term up. So the negative 29x is becoming negative 25x minus 4x plus 100. Factoring out the common factor of the first 2 terms, x times x minus 25. Factoring out the common factor of the last 2 terms. They have a negative 4 in common, x minus 25. Notice that when we factored out the negative 4, we made sure to change the sign inside the parentheses so that negative 4 times negative 25 is positive 100. And we also then have what's inside the parentheses matching. X minus 25 is the same in both sets of parentheses, so we can factor out that common factor, the x minus 25, which leaves us with what they don't have in common, the x minus 4 inside our new parentheses. We have factored. X cubed minus 5x squared minus 6x. So these 3 terms have a common factor. They have a common x. So we're going to factor out their common x, which leaves us with x squared minus 5x minus 6. Off to the side, we're going to multiply the first and last terms inside the parentheses. So with the common factor factored out, we get negative 6x squared. What multiplies together to be negative 6? Negative 1 times 6, negative 2 times 3. Negative 1 plus 6 is positive 5, so if we switch them, 1 times negative 6 gets us the 2 that add together to be negative 5. Excuse me. Whew, that was a good one. So then we split our middle term up. X squared minus 6x plus 1x minus 6. And we're going to factor out the common factor of the first 2 terms. I'm going to change the outside parentheses to brackets because I am factoring out a common factor. So I'm going to use parentheses here on the inside. Also factoring out the common factor of the last 2 terms. They have a 1 in common, x minus 6. What's inside the parentheses matches. You don't really need now that outside set of parentheses, because everything is being multiplied together. X on the outside times the brackets. inside the brackets, there's just two things multiplied together. So we just have three things all multiplied together. One thing that is awesome about this method is if we change example A to x squared minus 29x minus 100, when we're making our list and we do 1 times 100, 2 times 50, 4 times 25, 5 times 20, 8, 9, 10 times 10. Should have been negative 100. There we go. When we add those together, none of them equal 29. If you don't believe it and you want to check the other multiples too, 1 times negative 100, 2 times negative 50, 4 times negative 25, 5 times negative 20, and 10 times negative 10 still. None of those add together to be negative 29. Whoa, what's going on, Trippy? It's okay, that just means it does not factor. One of the greatest parts about this method is it gets you the ones that don't factor. Making this list is easy. It's something that you can always do. We're going to do some really crazy lists this year because they work on number sense, which is something we definitely want going on in mathematics. But it also gives you a very legitimate way that's quick to answer, does this trinomial factor or not? In pre-calculus, you're going to get problems randomly thrown in that just don't factor, that aren't easy to see that they don't factor. And you can spend a lot of time running around in circles trying to factor it because you want it to be able to factor. It feels like it should factor. But it doesn't. All the problems that I spent the most time on were ones like this that just don't work. They don't tell you, figure out whether it works or not. They just tell you to factor. They expect you to know that part of factoring is being able to say when things don't factor. And so we have to have a legitimate method for doing this. There's other methods that you can learn that are great methods. The methods that I use in Algebra 2 and Pre-Calc are try 3 times one of these other methods, and then if it doesn't work, make this list that I'm talking about, because that'll tell you whether it does or does not factor. If you can't get it in your first 3 attempts in a different method, then you need to stop using that method. It's just that simple. Zero product property. And factoring trinomials that are a little beefier. So in A, we have 5x squared minus 16x plus 12. We multiply the first and last together because they don't have anything in common. So 5 times 12 is 60. 60 is 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, and 6 times 10. Negative 6 times negative 10 add together to be negative 16, our middle term. That's our scratch work off to the side under our actual problem now. 5x squared minus 10x minus 6x plus 12. Factor out the common factor of the first 2 terms. They have a 5 and an x in common, leaving us with x minus 2. Factor out the common factor of the last 2 terms. They have a negative 6 in common, leaving us with x minus 2. The x minus 2's are the same, and so we can factor out the x minus 2. And we have our 2 factors. We factored, we're done. This is that same process that we were doing. A lot of times people get in a lot of trouble when they get here because of the number that's in front of the x squared. that number throws people off because they learn lesser methods of doing this, which unfortunately often don't work when there's a number in front of the x squared. So know that I'm not trying to trick you, that this is just actual factoring. We're expanding whatever types of factoring you may have learned into real factoring, being able to do all of factoring. So looking at 2x squared plus 5x minus 3, none of the three terms have anything in common, so you multiply the first and last together and get negative 6. Negative 1 times 6, we don't have to go any farther, because negative 1 plus 6 is positive 5. So 2x squared minus 1x plus 6x minus 3, x times 2x minus 1, plus 3 times 2x minus 1. What's inside the parentheses matches, and so we can factor it out. 2x minus 1 times x plus 3. And our last one, zero product property. Negative 24x cubed minus 78x squared minus 18x equals 0. So we have that beautiful equals 0 in there, which means if we can factor on the left-hand side, we can then solve for what x's make that true. They do have common factors this time. They have a negative 6 in common, and they have an x in common. So we're going to factor out that negative 6x, which leaves us with 6 times 4 is 24. 6 times 13 is 78. And 6 times 3 is 18. Inside the parentheses, multiplying the first and last together, we get 12x squared. 1 times 12. We don't have to make any more of the list because 1 plus 12 is 13, which is our middle term. And so we split our middle term up. 1x plus 12x plus 3. Most people like to change to brackets because we're factoring out what they have in common. We have a common x. And we have a common 3. We have factored, which is awesome. But now we have that equals 0. We have things multiplied together that all equal 0. If things multiply together to be equal to 0, then each one of those factors might be 0. So either negative 6x equals 0, or 4x plus 1 equals 0. Ooh, that's a terrible 4. There we go. Or x plus 3 equals 0. 3 small equations to solve. Division property of equality gets us the first one. The second one, we use the subtraction property of equality and the division property of equality. And the last one, we just use the subtraction property of equality. Either x equals 0, or x equals negative 1/4, or x equals negative 3. There you go. There's factoring trinomials. Process this, think about this, come with questions ready tomorrow, and have a lovely night.